Okay, this is just about JFET still. What I did was I still got the same exact configuration that I had for testing in the last video, but I went ahead and put my probe you know, instead of having it measure the voltage across the device like I just was, I went ahead and put it back to where I'm measuring the voltage, input. Just and I was using the exact same parameters. I'm trying to come up with a way where I could easily switch between family of curves versus the transconductance curve. Just out of curiosity, but I decided for shits and giggles, to go ahead and actually have both of those function generators fed with a triangle wave, which you can see here, and they're actually at different frequencies. So and you can see what the results are. So it's kind of interesting, seeing the just I thought it was kind of amusing, to see the interesting waveforms that were formed from this combination, which is just purely by accident. Let me turn persistence on, and you can see what happens. Does that curve look familiar? That's the transconductance curve. It's just kind of filling in all these levels. So I mean, if I turn um, this back to DC, let me turn. Oh, persistence is off. You can see what I was able to do. I was, changing the voltage level manually just so you can plot out the curve. Again, I'm just trying to come up with a convenient way to switch between curves, because the family of curves are interesting because they show you where the ohmic regions actually are. So you can kind of like, that's something you can sort of draw an actual load line across, like you can with bipolar transistors, and kind of see where your operating region would be, because you want to keep it out of the ohmic region. Um, but anyway, I just was fucking around here, and I thought this was so amusing I had to make a video about it. But yeah, this is just really kind of cool. I could change the frequencies, I'm sure, but it's almost like a liciduous pattern, of sorts. It's just a very interesting little discovery. I mean, sometimes I make little discoveries like this by fucking around. But yeah, putting persistence mode on, makes these cool patterns and stuff. But you got a clear, indication of where the, curve is, and if you wanted to bias this for use as an amplifier, you can very clearly see, from the transconductance curve, not just this one, but even the one I did, in earlier videos, you can clearly see where the linear regions are. I mean, this is where you'd want to bias your amplifier for it, set your Q point right around here or so, because you can see how linear it is here. You want to keep it definitely away from down here, which is near pinch off. Um, it's like I said, you become a lot less linear down there, so you keep it, close to full blast, and you get, good current response and so forth. So, I mean, you know, it's just kind of, it was just kind of cool, to see this unexpected result here, which happened completely by accident on this thing. So, at any rate, cheers.